Welcome and hello. This is a video tutorial using HEC HMS, and in this lesson we will be discussing forecast alternatives, specifically initializing values. In this lesson we will see how to set the initial parameter values for subbasins and reaches, as well as initial values for base flow, reach outflow, and reservoir elevation. What I have on the screen here is my model I have built. There's a couple reaches, I think 3 reaches, 5 subbasins, and an outlet here on the far east end. First, what I have to do to introduce this topic is to demonstrate what zones I already have in place. So if I go up to Parameters, Zone Configuration Manager, or this is a zone configuration. One is for a reach zone. So if I check out the zones within that configuration, it's just called all reaches. And if I look at those elements, I have reaches 1 and 2. And actually, I want to add, 1 and 2 need to get added. Reach 3 is already in there. Okay, that's good. And then we also have subbasin zone configuration. And if I click on the zones, you can see I have a lower subbasin zone and upper subbasin zone. If I click on elements now, you can see subbasins 4 and 5 are in the lower subbasin zone, and subbasins 1 through 3 are in the upper, which refers to elevation. So here is 1 and 2 is a small subbasin right down here. And then subbasins 4 and 5 in the lower, and then subbasins 1, 2, and 3 are in the upper zone. And already I set up a compute forecast alternative. I have a forecast one right here. That's just what I called it. If I click on the Compute tab here in the Watershed Explorer and then click Forecast 1, you can see the parameter data I have set up. So I'm using the Basin 1, Met model. And I've also set the zone configuration for the loss rate, transform, base flow, and routing to subbasin and reach zones. So all of this needs to be set up and ready to go before we can specify the initial values. If you go up to compute, now we can go ahead and click on the tools in this menu right here. So take, for instance, subbasin 1. It's using all the subbasins, for instance, are using the same methods of loss, transform, and base flow. So I can just quickly look at the values using the global editor. I'll unselect that subbasin, go up to parameters, go to transform, Clark unit hydrograph, and now I see the 5 subbasins and their values for time of concentration and storage coefficient. These will be the initial values that are used, and I can do the same thing with loss. So if I go up to parameters, routing, they're all using the Muskingum routing method. Here are reaches 1, 2, and 3. I want to actually capitalize reach 3. 1 second. Close. That's reach 1. Right click, rename. Okay, reach 3. Parameters, routing, Muskingum, and then no filter. Okay, it reaches 3, 2, and 1. There we go. Those are the values. Let's say, for example, we want to run this forecast alternative with different initial values, then we can override those initial values that are saved in the elements themselves by going up to compute, forecast parameter tables, and now we have our options for the loss method, transform method, base flow, or the reach routing. Let's click on transform for the Clark unit hydrograph. And what I have here is a table that shows me on top is the zones, and then on the bottom are the individual elements within that selected zone. So I mentioned we have 2 subbasins for the lower zone, and then we have 3 subbasins, 1 through 3, for the upper selected zone. What you're seeing down here are the actual values associated with those subbasins, but this top table here shows the area average values. So take, for instance, the time of concentration is 2, 3, and 2.5. So based on the area of these 3 subbasins, that area average is 2.4. Similar deal with the storage coefficient, 2.5, 4, and 3 hours. That area average comes out to 3.1 hours. And it's same with the lower subbasin, but this is lower subbasin is dominated by subbasin 5 because subbasin 4 is very small. So I'm going to just continue the discussion using this upper subbasin zone. If I wanted to overwrite the individual values globally, I can go ahead and make an adjustment here. I could type in like a plus 0.2 if I wanted to add 0.2 hours to that time of concentration for all the subbasins in that zone. So if I did that and then I clicked apply, what we see down here in this table is the initial values and then the final values, which have been corrected by adding 0.2. We can also subtract, and then we can also multiply. If I do times 1.1. That would be increasing the value by 10%. Okay, so let me click apply. Now what we see down here is 2 changed to 2.2, 3 changed to 3.3, and then 2.5 changed to 2.8. Well, 2.75. Okay, we can make the same adjustments over here. We can multiply by 0.5 and then click apply. Now we have newly calculated values for the storage coefficient. All right, so that's how that works. I'm going to go ahead and delete these values though and apply. Again, the same can happen for different zones. That was just the upper zone. And the same is true with the other hydrologic elements. So if I go back to compute, forecast parameter tables, and then clicked on loss, I'm using the initial and constant loss method. Here again, we have our subbasins. And if I click on the upper subbasin zone, what I'm doing here is multiplying by 1, so it really has no effect. But that initial loss may not always be zero point 0.2. For instance, if a storm has been going on for a number of hours or even days, we may want to change that initial loss to 0. We could just multiply by 0 up here and then click apply. So that would change globally. But what you're seeing down here in this bottom table is an override. So if I wanted to override a specific value or values that don't conform to the global edit on this top table that applies to all the subbasins in the zone, I can just, click this checkbox and then just type in the value I want. So I maybe want 0.1 and then apply. And then 0.1 will be used because that overrides the global edit. So I'm going to go ahead and apply, click close. Yes. If we look at the base flow, we have base flow parameters, works the same way, as well as the routing parameters right here. So routing, I only have one zone for all the reaches. I just called it all reaches. I have 3 reaches here. Here are the values. If I want to multiply, add, subtract, whatever, the K parameter or the X parameter for the Muskingum routing method, then I would do it the same way. And then also I have that option to override over here. If I go back up to that compute menu, the next 3 items sort of work together. It's basically to adjust the same parameter values like we did, either on a zone basis or an override individual basis by using a slider. So what we first do is select which elements we want to change and then set the slider range, and then we actually make the change right here. So I already have initial and loss set, and that's because if I go up to what I have selected here, I have the initial loss method. So I'm going to just remove those, just starting over here. Okay, so I want to go ahead and select the elements. So I have initial loss, the transform method, base flow, or reach routing. Let's stick with the transform method. I'll click on upper subbasin. Here are the 2 parameters. I'll add both of them and then click select. So I'll close that. Okay, these are tabs right here. So let me make it a little bit wider. Okay, so here are the different tabs across. These are the 2 parameters that I've selected for the transform method. So I'll close that. Now what I want to do is go to compute. I can set the slider range. So what I'm seeing here is under the Clark transform tab, the range is from 0.0001 to 5. But maybe like if I want to multiply it by something, it wouldn't be quite that dramatic. Maybe 0.5 and then 2. So I'll do that for both parameters. Click apply, close. And now finally we get to actually use the sliders. I'll go forecast parameter sliders, transform Clark unit hydrograph. And then I want to select the upper subbasin. And now here are my 2 parameters. There's time of concentration and storage coefficient. So let's go ahead and make a change here, save it, and then go back to that first table and just confirm that those changes were saved. Also, I want to uncheck this checkbox unless I want it to compute every time I move the slider. That's something I like to control manually, especially because my model isn't really even set up to compute yet. All right, let's go ahead and multiply that time of concentration by 1.3. I'll just type it in. And then the storage coefficient, let's multiply that by 0.9. Okay. All right. So we'll go ahead and click apply and then close. Now let's go back to our previous table here, which is right here. And then we're multiplying by 1.3 and 0.9 to get our final values, which are the initial values for the forecast of time of concentration and storage coefficient. The slider adjustment is an alternate way to view and change a zone parameter adjustment or an element parameter override. So yeah, just as before there was an element override for that first table, we can also use the element override with sliders. So I would do that by clicking on this, click on Clark Transform. We'll go ahead and remove both of these. If I wanted to just use the slider for just one subbasin, then I would click on Select, click on Clark Unit Hydrograph. Let's go with Upper Subbasin. Subbasin 1, down here is where we have the overrides, and say we only want to change the time of concentration. So we're creating a slider for that, for Subbasin 1, for Clark Unit Hydrograph, in the Upper Subbasin Zone. Okay, that's selected. I'll click Close. There it is. Close that. And then let's go and actually move the slider, which is right here. For the zone, I'll say it's the upper zone. Okay. And now we have subbasin 1 right here. It's not for every subbasin in the zone. It's just for subbasin 1. And we can go ahead and change that to whatever value we want. Oops. Okay. So it was starting to calculate there. Let's move on. All right. Next, I want to talk about changing the initial value for the subbasin base flow, reach outflow, and reservoir pool elevation. So let's start with the subbasin base flow. If I click on any subbasin here, you can see we're using the linear reservoir base flow method. And if I click on the base flow tab, you see I have a initial type is discharge per area, and I'm using 0.95. And then this subbasin is also using discharge per area, but 0.8. I go up to parameters and then base flow, linear reservoir, and then let me say there's no filter. Now we have my 5 subbasins here in the global editor view where I can see all the parameters side by side. So this column right here is the initial base flow value. And for all 5 subbasins, I'm using that discharge per area method. All right, so maybe we don't want these specific values. Maybe when we want to scale them up, scale them down, override them. I'll show you how that works. Go to the compute menu, forecast initial subbasin base flow. All right, as before, it's divided into zones. So we either select a lower zone or upper zone. I'll stick with upper zone for now. This table extends over a little bit. Right now, what we're seeing for estimated value is in CFS 10, 8.2, and 3.6. So where it's getting these values is it's multiplying the area of the subbasin times that CFS per area. So in the case of subbasin 1 here, we have an area of 12.628. So if you multiply that by the base flow of times 0.8, that comes out to 10. So that's how that's being calculated. Okay, let me go back here and I'll select upper subbasin again. All right, so that's how 10, 8.2, and 3.6 are being used. But we can just override it. I could just type in a number right here and say it's actually 9, apply, and then that's what it would be used. If you don't use this override, all these initial value overrides are optional. And if you don't put a value in, then it would just use the estimated value here. Also, what you're seeing is a drop down for discharge gauge. This allows the user to select a discharge gauge. I have a couple discharge gauges already saved here. And right now it has an observed flow rate. But if this observed flow rate is less than a specified minimum or above a specified maximum, I can set the default value that should be used instead. And then the final actual value here is the observed value times the ratio I type in right here, which may be 1 if one discharge gauge represents the entire subbasin. But if a discharge gauge represents multiple subbasins, then what I might want to do is use the exact same discharge gauge for all subbasins, but then the ratio of flows would be a fraction of 1, but they'd probably add up to 1. Next up is the reach outflow initial values. So what we need to do is make sure we have a zone configuration set for our reach, which is right here. Reach zones is what I'm calling mine. And then go up to the compute menu, forecast initial reach outflow. Now we have a table that looks just like the one we did for baseflow, where we have the estimated value right here. That's the default value that was set in the components editor for that reach. We have a final value right here, which we can override, or we can specify a discharge gauge, which would have an observed flow and then the same controls as before with minimum, maximum, default, and then ratio, which is multiplied by the observed flow to get that final calculated value. And the last one is the reservoir pool initial elevation. So let me close this here. I do have a reservoir in my basin model right here. And over in the components editor, you can see that I'm using elevation for my initial conditions with an elevation of 1460. So make sure you have elevation set here. Once you do, go ahead, go to compute menu, forecast reservoirs. And here we are. Once again, we can select the final value right here, which is the override. We have the estimated value of 1460. That's what we have in our model here for the reservoir element, but we can do the manual override right here. And I should also mention that there's a few other parts to this forecast reservoir elevation. For instance, discharge time series data handling after forecast time for all reservoirs. We have a choice between of three methods here to replace all the missing values with the last, replace the missing value with zero, or replace all the values with zero, even if they're not missing. And then below that, we have a tab for start time and forecast time. For start time, we can specify the gauge. And if we do, we could also type in the observed flow, minimum flow, maximum, and default. There's no ratio to this table because one stage gauge is going to be representative for each reservoir. The start time tab is where a start gauge may be selected for each reservoir. And then here on the forecast time tab, it allows the reservoir storage to be reset at the forecast time of the alternative. And these fields are grayed out here, but it would just basically be a copied over from what we see in the start time tab. Well, that will be it for this lesson. We talked about setting the initial values, parameter values for subbasins and reaches, as well as the initial values for base flow, reach outflow, and reservoir elevation when running forecast alternatives in HEC HMS.